Hey guys, it's Sam. Today we're going to do some more steeper ed minus, flatter ed plus. We're going to work through an example or two to try and simplify this topic and help us with our contact lens fitting. So before we get started, if these videos are helpful, please go ahead and subscribe, like the video, send me your comments. Today we're actually doing this video because one of the viewers, Nikki, said, hey, can you do another example of this? So here we are, and we're going to try and kind of simplify it and help explain some of the points. Really, to start this, we ask ourselves why. Why is there a steeper ed minus, flatter ed plus? You know, you may know the steps to get through the exam, which is really, I gear these videos towards that, towards helping you pass your NCLE examination. But really, we want to understand the why to it as well, because that's how we're going to become better opticians, better contact lens fitters. So sometimes with the contact lens prescription, we may need to tighten the lens, or we may need to loosen the lens. And one of the ways you can do that is by adjusting the base curve. But when you adjust the base curve of a gas permeable lens, it's going to affect the tear lens, the lacrimal lens that rests between the back surface of the contact lens and and your cornea. So we know that that space will fill in with the tear film, and it creates a lens. So before we go to the example, I want to draw some illustrations to help make this point stand out. So if we have a contact lens, a standard gas permeable, we're going to do something called fitting it on K. And when you fit a contact lens on K, what you're doing is you're fitting it to the flattest curve of the cornea. Remember, the cornea is measured with the keratometer, and it's measuring the dioptic strength of the cornea along various meridians. But if you could picture somebody kind of laying on their back looking upwards, this would be the cornea, right? So it's exaggerated, but if we fit a lens on K, then it's going to mirror the curve, the base curve of the cornea itself, right? So that's going to be, on K, we can think of it. It's on the flattest K reading. So when we fit something that is steeper than K, let's look at that. So if we have our cornea again, but let's say we want this lens really steep. So, and this will be, over exaggeration, called hyperbole, right? Just kind of really illustrating it. So a really steep base curve, and what's going to happen is, if that's our tear lens, right, our lacrimal lens that goes between, the base curve of the contact lens and the cornea, the anterior surface of the eye. So this is creating what looks like a plus lens. You can see that. So it's steeper than K. The lacrimal lens is a plus lens, right? And we know that, even from, regular eyeglass optics and everything, a plus powered lens converges light. So what we have to do, we have steeper ed minus, right? That's the acronym that we remember. So steeper ed minus, and what we're doing is when we add minus to the overall contact lens prescription, we are neutralizing this additional plus power here, so it kind of cancels it out. Because when you fit it steeper, adding a minus power to the contact lens prescription is going to get rid of that, effectively get rid of that lacrimal lens, so we can get the contact lens power we want and the base curve that we want, right? Because we don't want to throw the overall refraction, the prescription off, just because we had to steepen the base curve. So, and then we have, if we fit a lens flatter than K, again, if that's our cornea, and let's exaggerate this, right? It's flattening out the cornea, you could think of it as. Look at that. It creates, we all know that to be the shape of a minus lens, right? So it's going to diverge light. And so with a minus lens, so if we're flatter than K, we have a minus lens that's created. So we're going to do FAP, flatter ed plus, right? And that would be steeper ed minus, right? Because if you're fitting it steeper than K, it creates a plus power lens. You're going to add a minus power to your prescription, and it's going to neutralize it. Much like if it's a flatter than K curve of the contact lens, you're going to add plus to the prescription, and it's going to neutralize that minus lens that you created. So I hope that kind of helps to illustrate why we're doing this. And go ahead and erase that. All right, that is almost clean-ish. Okay, so I'm going to put up an example on the board, and we're going to kind of work through it. Let's see. And we will use axis 180. All right, very good. So there's a refraction. So I'm going to put some keratometry readings up here. Let's do 43 at, let's see, we'll do 180. And we'll do 43.75 at 90. Okay, so I did 43 at 180, 43.75 at 90. So before we get into this, I kind of want to go over a couple things. If we see our K readings, 43 and 43.75, let's point a few things out from this. So our flatter K reading is the 43. So 43 is our flatter K. If we were fitting the contact lens on K, it would be fitting it on that 43 base curve. So because the 43 is flatter, 43.75 is our steeper power of the K reading. Remember, and if you have regular astigmatism, these are going to be 90 degrees apart. Irregular astigmatism, like a keratoconus patient, your steepest and your flattest meridians are not 90 degrees apart. But this is regular astigmatism. We see that it's steeper along the 90 degree meridian. So we know that it's with the rule astigmatism. Anywhere 30 degrees next to 90 degrees, if you have your meridians laid out, your 90 is your vertical, your 180 is your horizontal. So it's saying that we have a steeper power at the 43.75. That's our corneal dioptric strength, or our K reading on the 90. So that's steeper on the 90. If you're within 30 degrees of 90, you know, if we did 120 and 60, if your steeper power falls in that, it's with the rule of astigmatism. And, you know, oppositely, if this was 43.75 at 180 and 43 at 90, your steeper power would be on the horizontal. You'd call that against the rule of astigmatism. And then if it fell in between those, it would be oblique astigmatism. But I digress. So what we see here, and what I was getting to before I took a rabbit trail, was that there's 0.75 diopters difference between our steepest and flattest meridians. And what that's showing you is the corneal astigmatism, because the keratometer is measuring corneal astigmatism. And we compare that with our refracted overall astigmatism, and we see it has the same amount of astigmatism. So what we can see right off the bat is that the corneal astigmatism matches your total astigmatism, right? So there's probably not any lenticular astigmatism, which is astigmatism with the corneal, the crystalline lens inside the eye, right? So we could tell that it's all corneal astigmatism. And we could also tell that it's with the rule astigmatism. And we know that with the rule astigmatism, you can use a gas permeable lens to correct up to 3 diopters of with the rule astigmatism. I'm going to kind of clean this up a little bit again. All right. So we have our refraction, we have our K readings. So we determined that it's corneal astigmatism, it's with the rule astigmatism. Another way to see what type of astigmatism it is you could transpose the prescription. So if we do that, we get, so you add the -75 and a -450, you get -5.25. You drop the cylinder value down, change the sign, and rotate the axis 90 degrees. So when you transpose, all you're doing is you're showing the flattest and the steepest power of the lens. Again, we see the most power along the 90. It's just, you know, proving that it's the with the rule astigmatism type. Just another way you can check yourself. But we don't need to transpose this because it's already given to us in minus cylinder form. And you have to remember, if you get a prescription in plus cylinder form, you know, the first thing you want to do is put it in minus cylinder form. We always work in minus cylinder form. So it's in minus cylinder form. Good deal. Next, we're going to, you know, remind ourselves what type of lens can we fit with this. Well, you could do a soft, you know, soft contact lens would work just fine. But if our options were gas permeable, let's pursue that option here. And our next thing, which we always want to do, is you look at the power, At negative 450, you say, is that above 4 diopters? If it is, we have to compensate for vertex distance. So minus cylinder, compensate for vertex distance. You always have to go right to those. I have a couple videos on vertex distance, 2 or 3 videos, so I'm not really going to labor over that point. But I will say, just as a reminder, all contact lens prescriptions are more plus or less minus than the refraction. So if someone's refracted at a minus 450, again, that's what they got in the foreopter, which is out here, which is about 12 millimeters away from the eye. So when we're putting that lens on the eye, you always have to, your answer, your contact lens prescription is always going to be more plus, less minus. So we know you're not really going to notice much of a difference, just 450 as your diopter, because it's going to take up to like 9 diopters to really make a huge difference where you're changing like even a full diopter potentially. So we're going to go just a little bit. When you do the vertex distance on this, you're going to go more plus, less minus. In this example, it's less minus. So after compensating for vertex distance, your sphere is minus 4 1/4. And then we're going to say, see you later to our cylinder and our axis. We're using a gas permeable lens. It's going to correct for that with the rule of astigmatism, so we don't have to concern ourselves with it, which is very nice. But now, so we're not done. If we were fitting this on K, if the question said fit this lens on K, we would be done. That would be my answer, negative 4 1/4, gas permeable spherical lens. But the question we asked, we said, I think we did a half a diopter flatter than K. And if we didn't, let's just say it was a half a diopter flatter than K. Right, so they want to flatten the K reading out. They want this lens to fit a little bit looser potentially. So what is our rule? Steeper add minus, flatter add plus. So flatter add plus. So a half a diopter flatter than K. So we're going to do negative 4 1/4 plus, flatter add plus. We're going to add a half a diopter. So when you add a 0.5, a plus 0.5, and a negative 4 1/4, you're going to end up with a negative 375 sphere. If you're fitting this lens a half a diopter flatter than K, your answer would be negative 375 sphere. So conversely, let's say we wanted to fit it a half a diopter steeper than K. We're going to still arrive at this answer. You've compensated for vertex distance. It's just in minus cylinder form. You determine the lens you want. That's your answer. But now we're going to do steeper than K. So steeper add minus. So we're going to do negative 4 1/4. We're going to add a minus a half. When you add a minus a half to a minus 4 1/4, you're going to end up with what? Minus 475. So steeper than K would be a minus 475 for your answer. So you can see you just have to reason through these examples, and they're not that bad. Just remember the order of operations. If this video has been helpful, if it's improved your studies, please go ahead and comment, like the video, definitely subscribe to the channel, and I'll keep putting out more great content to help you get through this test. Thanks so much.